Hello everyone, I am Anushka Srivastav. Welcome back to my channel. This is our second lecture. Let's see what are the topics that we are going to discuss today. Today, we are starting with data preparation. What do we understand by the term data preparation? Data preparation is the crucial initial phase in any data science project. It involves transforming raw, unorganized data into a clean, consistent, and usable format suitable for analysis and modeling. This process is often time consuming but is essential for achieving accurate and insightful results. Data preparation in data science is the process of organizing and transforming raw data into a clean, structured, and usable format for analysis. It's a critical step in the data science workflow as it ensures the data is high quality and is ready for further use. Let's discuss the key steps of data preparation. Number one, data collection. In this, we gather all the data from various sources, which may include database, API, and web scraping or manual entry. Step number two, data cleaning. Addressing missing value by imputing, removing, or using alternate strategies. Step number three is data transformation. Normalization or standardization data to fit a specific range or scale. Step number four is data integration, combining data from multiple sources into a single cohesive dataset. Step number five is feature engineering, creating new variables from existing data to improve model performance. Step number six, data splitting. Divide the dataset into training, validation, and test subsets for model developments and evaluation. Additionally, data preparation includes index field, misleading field values, re-express categorical field values, standardized numeric field using Python, and identify outliers. Our first is index field. Index field is nothing, it is just a column or value which helps to track the record uniquely in a dataset. Number second is misleading field values. Misleading values are incorrect or inconsistent data entries that can confuse analysis. For example, M and male might both appear in a dataset to represent the same value, but this inconsistency can cause issues. How to correct it? You can correct it by this following process. A third is re-express categorical field values. Re-express categorical field data involves converting non-numeric categories into numeric values. We convert this data in numeric data because machine learning algorithms cannot apply on non-numeric dataset. Standardized numeric field. Standardization is something like that we convert all the other units to a standard unit so that machine can understand perfectly and give more accurate output. Fifth is identifying outliers. Outliers are data points that differ significantly from the majority of data. This extreme value can affect the model's accuracy, so we need to identify and handle outliers appropriately. Also consider the following example. Our next topic is data preprocessing. Common steps in data preprocessing are as follows. Number one, data cleaning. Number two, data transformation. Number three, data reduction, data splitting, and data integration. What do we understand by the term data cleaning? Data cleaning is a critical process in data preprocessing that involves identifying and correcting error, inconsistencies, and inquiries in dataset. The goal of data cleaning is to improve the quality of data, making it suitable for analysis and modeling. High quality of data is essential for obtaining reliable insights and making informed decisions. Importance of data cleaning. Number one, improves data quality. Clean data leads to more accurate and reliable analysis, which is crucial for decision making. Number two, enhance model performance. Machine learning models trained on clean data are less likely to overfit and can generalize better to unseen data. Reduces error. Cleaning the data helps to minimize error that can arise from incorrect or inconsistent data entries. Number 4. Facilitate better insight. Clean data allow for clearer visualization and more meaningful interpretation leading to better insights. Our next topic is data transformation. Data transformation is another crucial step in the data preprocessing process that involves converting data from one format or structure into another. The primary goal of data transformation is to prepare the data for analysis and modeling, making it more suitable for the specific requirement of an analytical method or algorithms being used. This process can enhance the quality of data, improve model performance, and facilitate better insights. Importance of data transformation. Number one, improves model performance. Many machine learning algorithms perform better when the data is transformed appropriately, such as scaling numerical features. Number two, facilitate data integration. When combining data from different sources, transformation helps standardization, format, and structure, making it easier to analyze the integrated data set. Number three, enhance interpretability. Transformation data can make it easier to interpret and visualize, leading to clearer insight and better decision making. Number four, reducing complexity. By simplifying the data structure or reducing dimensionality, transformation can make the dataset more manageable and easier to work with. Let's discuss some data transformation methods. Number one, normalization or standardization. Scale numerical features to a common range, example 0 to 1, or standardize them to have a mean of 0 and standard deviation of 1. This is particularly important for algorithms sensitive to the scale of the data, such as k-means clustering and gradient descent based methods. Number 2. Encoding categorical variables. Convert categorical variables into numerical format using techniques such as label encoding and one-hot encoding. Third, feature engineering. Creating new features from existing ones to enhance the dataset. This can include combining features, extracting data components, and creating interactions term. Third step is data reduction. Data reduction is another crucial step in data preprocessing phase, aimed at reducing the volume of data while preserving its essential characteristics and integrity. The primary goal of data reduction is to improve the efficiency of data preprocessing and analysis, making it easier to work with large data sets and to mitigate issues such as overfitting in machine learning models. Techniques for data reduction. There are few techniques for data reduction. They are number one, feature selection. This process involves the selecting of subset of relevant features from the original dataset, thereby reducing the number of input variable. Number two, dimensionality reduction. This involves transforming the data into a lower dimensional space while retaining as much variance as possible. Number three, data compression. This involves encoding the data in a more compact format to reduce storage space and improve processing speed. Number four, data aggregation. This involves summarization or aggregating data to reduce its size. For example, instead of storing individual transaction record, you might store daily sales total. Number 5. Sampling. This involves selecting a representative subset of the data for analysis rather than using the entire dataset. So our fourth step is data splitting. Data splitting is a critical step in the data preprocessing phase of machine learning and data analysis. It involves dividing a dataset into distinct subsets to ensure that models are trained, validated, and tested effectively. The primary goals of data splitting is to evaluate the performance of a model on unseen data, which helps in assessing its generalization ability. Data splitting techniques are as follows. Number one, random splitting. The simplest method where the data is randomly divided into training, validation, and test set. This method assumes that the data is representative and that random sampling will yield a good distribution of classes. Number two, stratified splitting. This method ensures that the proportion of class in the training, validation, and test set is similar to the original dataset. This is particularly important for imbalanced dataset where some classes may have significantly fewer instances than others. Number 3 is leave one out cut cross validation. A special case of k-fold cross validation where k is equal to the number of data points Each data point is used once as a validation set while the rest serve as the training set. This method can be computationally expensive but is useful for small data set. Number 4. Series split. For time-dependent data, traditional random splitting may not be appropriate. Instead, data is split based on the time, ensuring that training data precedes validation and test data. This method respects the temporal order of the data. Our first step is data integration. Data integration is the process of combining data from different sources into a unified view, enabling comprehensive analysis and decision making. This is particularly important in environments where data is collected from multiple databases, applications, or systems, which may have different format, structure, and semantics. Techniques of data integration are as follows. Number one, ELT, that is extract, load, and transform. In this approach, data is first extracted and loaded into a target system, and then transformation are applied within the target system. This is often used in modern data architectures, especially with cloud-based data warehouse that can handle large volume of data. Number two, data federation. This technique This technique creates a virtual database that allows users to access and query data from multiple sources without physically moving or consolidating the data. The data federation provides a unified view while maintaining the data in its original location. Number 3, data virtualization. Similarly to data federation, data visualization or virtualization allows users to access and manipulate data from various sources in real time without the need for data replication. It provides a layer of abstraction that enables seamless access to data. Number 4, data consolidation. This involves merging data from different resources into a single repository. Data consolidation may require scheme integration where different data structures are aligned to create a unified schema. Number 5, API integration. Many modern applications expose APIs that allows for the integration of data between systems. API integration enables real-time data exchange and interaction between different applications. So here we have covered each and every topic briefly. Stay tuned for further lectures. Thank you.